Welcome everybody. We're on lesson number 4. Now we're talking about polar coordinates. You might want to get a polar coordinate plane ready to go. Also, a unit circle would be handy for this lesson as well. You can get these from the website under the documents. So print out a couple of these or grab them from class. We're going to need those. Alright, so let's talk about polar coordinates. Look a little bit different than rectangular coordinates, right? We have an r value and a theta. We also have, instead of an origin, we have what we call the pole. And r is going to be the distance out from the pole, and theta will be the directed angle counterclockwise from the polar, we call it the x-axis, to that particular point. So here you would have a pole. This would be the x-axis of the polar coordinate plane, starting at 0 radians, and we would be traveling so many radians out a certain distance for that particular point. Okay, let's take a look at what the actual polar planes look like here. Right, you can see that each of these rings, right, we have 1, 2, 3, 4, 5, 6, 7, 8 of these particular rings. So depending on where our value falls, we're going to want to go out that far of a distance. And then you can see that we have radian measures up along the outside. We also have degrees, but we're going to be working in radians for these. Okay, you might actually notice there's a few extras than what we're used to working with. Right, we actually have pi over 12 show up a few times. Okay, so it's just giving us a little bit extra to work with on this coordinate plane, okay, polar coordinate plane. So let's actually start working with some plotting coordinates. Okay, we're going to plot these coordinates first. I'm going to label each one. Let's see if I can fit these both on the screen at the same time. Just barely. I'm gonna do that. It's gonna fly down. That works. Alright. So we want to plot those particular points. So the first one is 6 and 4 pi over 3. I like to do these first, and then I count out how far I need to go. That's just me. So let's see. 4 pi over 3 going clockwise is going to be over here. So I'm on this line, and I want to be out 6. So let's see. 1, 2, 3, 4, 5, 6. That's where it puts us. And that was A. Okay. B, they give us 3 and 5 pi over 6. So let's see. 5 pi over 6 is over here. So I gotta be 3 out. 1, 2, 3. I knew that was going to happen. Let's see. Problem C, 5 and negative pi over 6. Okay, so this is just telling us that we got to go clockwise, pi over 6. On this chart, pi over 6 is 2 spaces, but we got to go in the negative direction, so 2 spaces. This is the line that we're following, and we want to be out 5. Let's see, this is 8, 7, 6. 5 would be right here. And finally, negative 2 pi over 2. Alright, so this time we're actually going to pi over 2, but we're going in the negative direction. So I should be heading this way too, right here. Okay, you can actually use the same coordinate plane. What I would do though is I would write these down real quick, and I'm going to let go of the notebook. So write those down, plot them, and then resume the video when you're ready to check. Alright, let's see. So we want 8 and 11 pi over 12. So 11 pi over 12 is, let's see, here, and we want to be at 8. So that should have been your first point. Next we have 2 pi over 3. 2 pi over 3, 7, 6, 5, 4. Negative 3, 5 pi over 4. So we're going to do that part first. 5 pi over 4 is right here, but we're going in the negative direction. So 1, 2, 3. Put this right here. And then last, 7, negative pi over 2. So let's see. Pi over 2 is right at the top. So negative pi over 2 would be at the bottom. And how far were we supposed to be here? 7. Yeah, right here. Okay, hopefully you got all those points correct. Because polar coordinates are really pretty easy to plot. Alright. Now, we got to do a little bit of mathy stuff before we can start doing the fun graphing stuff in the next lesson. So we're going to do a little bit of math here. Mathier math than plotting. Alright, they give us these formulas, right? If we're given r and theta, we can actually plot the same point with a completely different coordinate, which that's unique to a polar axis or a polar plane, because on a rectangular system there's exactly one point per coordinate, versus here we can have multiple coordinates show up at the same point. How it works is two options. We could make r negative, as you saw with the last problems, it makes us go in the opposite direction, or we could keep r positive and we could circle around our unit circle so many times. Okay, this particular formula is a little tricky, by the way, right? You notice that you have a plus or minus, so you can go in either direction. It's not tricky, I should say. It gives you options. Anyways, you have a plus or minus, so you can go in either direction. Same here. This one, however, is going to be giving you not necessarily a full circle around, but half a circle, which makes sense because then you're going to be traveling the opposite direction, which will put you back to where you began. So we're going to use each of these for these examples down here. All right. We want to find 3 other coordinates between negative 2 pi and 2 pi for 5 and 2 pi over 3. So let's see. First, we can change r so it's negative. So we have negative 5. Then we're going to take our theta. We're going to add 2. Now, what I'm going to do with this particular function is I'm going to pick 0 for n. And I'll show you why in a second. I'm picking 0 here because that goes away, right? That's just 0. And when I do my distribution, or if I add, doesn't really matter, I have 1 times pi. So all I'm really doing here is adding pi. That's why I picked 0. This pi is really over 1, so I'm going to have to multiply it by 3, both top and bottom. So let's see, that gives us negative 5 and 5 pi over 3, which is inside the unit circle, or I'm sorry, within our range. The next one we're going to do, very similar to this one, right? We'll choose negative 5, but this time instead of adding, we're going to do the subtraction. So we're going to have 2 pi over 3, and we're going to subtract all of this again. That goes. So essentially, I'm subtracting what I did down here. Which gives us -5 and -pi over 3. And the last one will keep the same. We're going to do theta. Now, we're not really sure if we need to add or subtract, because remember, we do have a certain range we got to stay inside of. But I'm going to choose not 0 here, because that'll get rid of the addition altogether. So I'm going to choose 1 this time. Oh, I'm sorry, I put theta here. I'm supposed to put the actual value. 2 pi over 3. 2 pi over 3. Alright, I'm sorry about that. So, we're taking 2 pi over 3. We're going to either add or subtract 2 pi, which is really over 1. So let's see, 2 pi over 3 plus or minus, that's going to have to be 6 pi over 3. Now, the reason why I haven't chose add or subtract yet is because up until this point, I really wasn't sure if I needed to add or subtract. If I add, that's going to give me 8 pi over 3. That's beyond 2 pi. So adding is out. If I subtract, that will give me -4 pi over 3, which is still within. So I want to go with the subtraction here. So 5, that gives me -4 pi over 3. Now, if you're not convinced quite yet, our original coordinate was 5 and 2 pi over 3. So that's right here. And let's check out all these other ones. Right? 5 pi over 3, and they want us to go in the negative direction, land in the same spot. This one says -pi over 3. So let's see, pi over 3 is here, -pi over 3 would be down here, and we go -5. Land in the same spot. And then 5, -4 pi over 3. So let's see. 4 pi over 3 is way over here, right? We went all the way around. 2 spaces, basically, away from this axis. So if I go the negative direction, I'm going to land here, right? 2 spaces from this axis, just going the other way, and I want to be out 5. So each time we landed in the same spot. So if you weren't convinced, now you should be. Okay, you've got one to try here on your own. Find 3 coordinates between -2 pi and 2 pi for this coordinate 2 pi over 4. Pause the video, resume it when you're ready to check. Alright, let's see what you came up with. Let's do the -r, right? So -2. We're going to take pi over 4. We're going to add 2 times 0 plus 1 pi. I'm choosing 0 to get rid of that altogether. So let's see, -2 pi over 4 plus, let's see, that's just pi. I need this to be a 4 on bottom, so I'm going to multiply by 4 and 4. Which gives us 5 pi over 4. That's one of them. We can do pretty much the same thing here, right? But I'm going to do subtraction at this point. So pi over 4 minus 5 pi over 4. That's going to give us -3 pi over 4. So that's our second one. That was using both of the -r options. And then finally, we could do pi over 4 plus 2 times 1 pi. So let's see. That's pi over 4 plus 2 pi. So that's going to be 8 pi over 4 if we want to. Alright, but now here's the problem. Remember, I said plus, but let's see. It looks like plus isn't going to work, is it? 9 pi over 4? No, that's past 2 pi. So the addition doesn't work here. We've got to subtract. So that's going to be negative 7 pi over 4. Alright. Almost done with this lesson. And then we only have one more lesson to go. So let's finish this one up. Stop talking. Get back to work. Alright, coordinate conversions now. Okay. What if we are given something in a polar coordinate, but we want to know where it would land on a rectangular plane? Or what if we're given rectangular and we want it to land on a polar plane? I can't tell you how many times I've been in this situation in my life where somebody starts talking polar coordinates to me and I'm like, yo, I only speak rectangular, so we got to convert them. So it does happen. It also probably happens a lot geographically and stuff like that too. I'm sure that there are definitely a lot of reasons to do this, but let's get to it. Right? If we're given polar and we want to convert to rectangular, for x we do r times cosine of theta. For y we do r times sine of theta. These make sense too. Remember how sine in how cosine was x and sine was always y, so those work real nice. And then if we're given rectangular and want to convert to polar, well, to find theta, we can do tan of theta is equal to y over x. Basically, we're finding the inverse tan of y over x. Okay? And then here, to find r, we use r squared equals x squared plus y squared. But even better than that, let's take the square root already. So we know that r is going to be x squared plus y squared. Okay, so that's what we're going to use instead of this. So these formulas, hopefully you have them written. We're going to do a couple examples. We want to convert to rectangular coordinates for this first. So we're given polar, we're going to go to rectangular, we got our x and our y. Hopefully you have a unit circle, or really, I suppose you could probably use these, no, a unit circle is going to work way better. Alright, so we're doing for x 5 times cosine of 3 pi over 4. 3 pi over 4 on our unit circle comes out to be negative root 2 over 2. And then if we multiply these, we're going to end up getting negative 5 root 2 over 2 for x. So that's my x coordinate. For y, well, 3 pi over 4 for sine was positive root 2 over 2. So when I multiply these, we get positive 5 root 2 over 2. So here is the rectangular version of this polar coordinate. Now, that's if you had the units lined up nicely. If you were to take like one graph and put it right on top of the other, that's where it would land. Let's check it out with this particular problem. All right, 11 pi over 6. So let's see. X is going to be 3 times cosine of 11 pi over 6. Check out the unit circle. Let's see, cosine of 11 pi over 6. That's root 3 over 2. So let's see, multiplying those. 3 root 3 over 2. That's our x coordinate. Y, we do 3 times sine unit circle says sine of 11 pi over 6 is -1/2. So we're getting -3/2 for y. Okay, actually not too bad, especially, like I said, if you have the unit circle handy, pretty easy to do. Okay, we're going to leave them in a radical form. No need to give me decimals for right now. So you've got one to try here. I'll leave these up as a reference. Pause the video, resume it when you're ready to go. Alright, let's see how you did. For x, we want x times cosine of 3 pi over 2. Let's see, 3 pi over 2, that's 0 for cosine. So we get 0 for our x-coordinate. Y is going to be 6 times sine of 3 pi over 2. 3 pi over 2 for sine is -1. So we get -6. 0, -6 is the first coordinate. That was a pretty easy one, huh? Let's see. X equals -2 times cosine of pi over 6. Let's see, cosine of pi over 6, that's √3 over 2. All my 2's are going to go. Negative times √3. Negative √3 for our x-coordinate. Now for y, -2 times, let's see, that would be 1/2. The 2's again to cancel. Negative times 1, that's -1. You get those two coordinates. I hope you did. Converting from polar to rectangular, pretty straightforward. Going from rectangular to polar, a little more tricky with tan involved, but you know, what are you going to do? So let's do these problems. First, we need to find r. R is equal to x squared plus y squared. So let's see, that's going to be 16 plus 16, which is 32. I'm just going to leave that how it is. Technically, we could reduce that, but that's fine. Now, tan of theta needs to equal 4, right, y, divided by x, which is 4. So we need to figure out when is tan of theta equal, that's 1. Well, let's see. Tan of theta is equal to 1. Basically, anytime that we have the same number dividing itself like we saw here. And that's going to end up happening at pi over 4. So we got √32 and pi over 4. Another one here. Let's see. R equals square root of 1 squared plus 0 squared. That's nothing. Square root of 1 squared, that's just going to give us 1. Tan theta equals y over x, so 0. When is tan equal to 0? That usually happens at pi. So it looks like this coordinate's going to be 1 and pi. Well, maybe not. Because 1, 0 suggests that we're going positive. And if we go pi, we would be on the other side of the unit circle. So we actually might need the other time that tan equals 0, which would be at not pi, but 2 pi. So I think that's a slightly better answer. Okay, we have one for you to try. That could actually come up in this next problem, so be aware of that. Pause the video and resume when you're ready to check. Alright, let's try this one out. R equals the square root of 0 squared plus 2 squared. That's nothing. Square root of 2 squared, that's going to go away. So we get R equals 2. Then we've got tan equal to y over x, which is undefined. Let's think of when tan is undefined. That happens at pi over 2 and 3 pi over 2. But 0, 2 would be going up. 3 pi over 2 is 3/4 of the way around, which is down. So we don't want the 3 pi over 2. We want the plain old pi over 2, which is going up. There you go. Kept this lesson under 30 minutes this time too. The next lesson is going to be graphing some polar functions. They actually look really cool. I think they do anyways. And then we're done with pre-calculus. That'll be the last lesson. So be prepared for that. It might be an emotional one. I don't know. We'll see. Alright, I'll see you there. Bye.